Hello and welcome to Lesson 1 of Unit 7, Features of Functions and Parent Functions. In this lesson, our goal is to review what we've seen in previous units, and we're going to be adding in this new vocab word called minimums and maximums. And so let's get started to review some pieces of information. So domain, that is a set of all possible x values. That is from left to right. We then have range. This is all of our y values, and this is the bottom of our graph to the top of our graph. Now, we always use parentheses for negative infinity and positive infinity, and we use brackets for included points. We then have this next thing called increasing, decrease, and decreasing constant. This is where our graph is going to be increasing, going up, decreasing, going down, or constant where our graph is flat. Now, as a reminder for all three of these, always use parentheses and only x values. Okay. And then x-intercepts and y-intercepts. These are where our graph crosses the x-axis and y-axis. So I'm just going to draw a quick picture. So our x-intercepts would be, we'd have 2 here because that's where our graph passes the x-axis. I'm going to draw that same picture. I have 1 y-intercept because that is where it crosses my y-axis. And so we're going to look at this graph to the right, and we're going to find each of these pieces of information. So I'm going to trace this graph real quick, just so we know, okay, it starts here, down, up, down, and it stops there. And so from that, our domain, 1, 2, 3, -4, is going to be bracket -4 to +4 with a bracket, because that's left, how far left we go, to how far right we go. Remember, domain and range is kind of putting our graph in a mini box. Now we're going to look at our range. So the bottom of our graph is at -2, and it includes, because that's that closed point, and the top of our graph is at +2. What we're going to do next is we're going to, and we talked about this in our previous unit, we use different colors for increasing, decreasing, and constant. I'm going to do the same thing again. So as I read my graph left to right, wherever my graph goes up, I'm going to highlight blue, and at the same time, I'm going to bring that color coding down. Decreasing wherever our graph goes down, so here and here, and we have no constant. So the next thing I'm going to do is I'm going to bring in those dashed lines, so that's at -2, and we change colors again at +2. Remember, those color codings are just nice because now we just have to bring those numbers over, -4 to -2, and 2 to 4, and there are none. Our x-intercepts, again, that's where we cross the x-axis. So we have 1 at -4, 0, and at +4. And then we have our y-intercept where we cross the y-axis is also at 0. And now, is it a function? This is asking yourself to use the vertical line test. We also called it the pencil test. That's where we take our pencil and we drag it across. So imagine this is my pencil. We are only hitting our graph everywhere once. So this is a function. Okay, so now let's go to the next page. And this is that new piece that we're going to be talking about. Turning points on graphs are the locations where the graph goes from decreasing to increasing or increasing to decreasing. This concept is summarized in the graph below. So let's take a moment and let's just color code it. So wherever my graph goes down is I'm going to color in blue. Wherever my graph is increasing, going up, I'm going to color in green. The reason that this is nice is it helps us find these things called minimums and maximums. And so we have this word relative in front of them. It just means that in that area, it's either going to be the lowest or highest. So maximum, this is going to be the highest point, and minimums are going to be your lowest point. And so a maximum, we're looking to see where our graph goes from increasing to decreasing. So I'm looking, that's why the color coding is nice. We're looking to see where we go from green to blue. So green to blue is here. So this point right here is a maximum. Now, a minimum, this is where we're going to be going from decreasing to increasing. So in my case, I'm going to be looking where we're going from blue to green. And in this case, we have 2. So this is a minimum, and this other point is a minimum. Okay, now let's look at this graph. So what I'm going to do first is I'm going to color code it again. And so I'm going to highlight where it goes from increasing to decreasing. So that's where my graph goes down. And then I'm going to highlight where my graph goes up, which is right here. Now, all we really care about are where they're changing directions. So this point right here is a minimum. This point is a maximum. And this point is a minimum. And to make my life a lot easier, I'm going to put the points below it. So that's 0, 0, 1, 1, and then 3, -1. So when we have 2 questions, where and what. So where, this is our x value. What is our y value? So where are the relative maximums? They are at 1. We only have 1. What are they? 1. So for number 4, we're looking for our minimums. We have 2. So where are they? At 0 and 3. What are they? 0 and -1. So now what we're going to do is we're going to take this and we're going to look at number 6 with a new graph. And so we're just bringing all of these pieces together. So our domain for this is bracket -2 to 6 with a bracket. Our range is the bottom of our graph, which is bracket -3 to +2 with brackets. Again, we're using these brackets because these are close points. We're going to be increasing, so I'm going to color code. Again, this is going to be nice for later when we find our minimums and maximums. So increasing is green, decreasing is blue, so that's where our graph goes down, and I'm going to make orange constant. In this case, we do. And so this is another way that you could also draw in those lines. So we change colors at 0, we change colors at 2, we change colors at 4, we start at -2, and we end at +6. Now all I'm going to do is I'm going to bring those colors down from my graph. This is just helpful, again, so we don't have to worry about what values we're working with. We're always working with the x values, and now I'm just going to bring them over. So we're green from -2 to 0, blue from 0 to 2, orange from 2 to 4, and green again from 4 to 6. Our x-intercepts, that's where we pass the x-axis. We've got 1, 2. So I would say that's about, because they're going at half, every tick mark's about is a half. So I would say like 0.8 and 6. Our y-intercept, that's where we're passing the y-axis, and in this case there's only 1, at 2. A relative max, remember, that's increasing to decreasing. So this point right here, what happens to be our y-intercept, is our maximum. And since it's not asking where and what, I'm just going to write the point. So that is 0, 2. And our minimum, now you might think that these, I'm going to use a laser. This point and this point might be minimums. However, as put up here, a minimum is increasing to decreasing. And so there is no specific blue to green, so there's actually no minimums. Okay, let's go to the next page. Okay, so practice. I'd like you to pause the video and try number 7 on your own. hopefully you actually did pause the video, and now we're going to go over it kind of quickly. So our domain for this problem is negative infinity to infinity. Our range is bracket -3 to infinity. Again, that's coming from our arrows pointing up forever and ever. We are increasing here. We are increasing, decreasing where our graph is going down here. And we are constant, I'm going to use the color pink, I'll use pink. We are constant where our graph is flat here. And so I'm going to bring, so we're at -1, 0. We start at negative infinity and we end at infinity. And so I'm going to bring those colors over to get my increasing, decreasing, and constant intervals. So maximum, there is nowhere that our graph goes from increasing to decreasing, so there's none. Our relative minimum, we actually do have one. It is at 0, -3, because that is where a graph goes from decreasing to increasing. And then our x-intercepts, this is where we pass the x-axis. I'm going to say maybe 1.9. Y-intercept is at -3. And it is a function because this is an open circle over a closed circle. Remember, open circles tell us we get super duper close, but we don't actually include that point. Okay, so technically your homework is number 8, and we'll go over it in class. So I'd like you to try it. But kind of going over the last page of your notes, this is a reference page for parent functions. So this unit is all about functions that you're going to be seeing throughout. The ones that we've seen so far are linear functions and exponential functions. In this unit, what we're going to be focusing on is absolute value transformations, exponential, and square root functions. This is all in Unit 7. We will see quadratics, super fun, later. So this is later. And you will eventually see cubic functions. This is more of an Algebra 2 topic. But the thing about parent functions is that they are our starting point. Okay, so like your linear function, this is your parent function graph. And your domain and range, you can tell a lot about it from your parent functions. What's kind of cool to notice is a lot of them are negative infinity to infinity. So I'm just going to highlight everywhere that it's negative infinity to infinity. See, a lot of them have it. When we have negative infinity to infinity for either our domain and range, no matter what we do to that graph, it will always be domain and range, or it'll always be negative infinity to infinity. And so this is where we're going to stop. Please come to class with any of your questions, and I will hope to see this problem done for your homework. Thank you.